In this video, we're going to model the base of our Rotiform LHR custom offset wheel. Hey everyone, this is Matt with Learn Everything About Design, and in the second part of this video series, we're going to get started creating our 3D model in Fusion 360. Now, if you're following along, make sure that you are using a file where you've created these references. I've downloaded all of the images from the Rotiform website from the link in the original video, and you can also download this data set by going to the description of the video, and then you already have those references set up. Before we get started, I want to clarify one of the topics that is the basis for this design. So we created two canvas images to represent where the rim itself is going to be and where the hub is going to be. And this was based off a sketch for the stock rim size. Now, this is problematic because when we sketched this, I used an 18mm offset value, and that's actually in the incorrect direction. So for a positive offset, the flange or the mounting position is going to be closer to the outside portion of the wheel. If we were to visualize this, we would see the mounting flange portion of the rim on this side of the wheel, and it's going backwards on our reference sketch. Now, it doesn't change the way that we're going to model the rim. Everything is still going to be created the same, but it's important to understand that there are these two different variables, this offset value and potentially a back spacing, a distance from the back of the rim to the back of the flange. Now, either of those can be used, and if you're representing a rim based on a off-the-shelf one that you're looking for, make sure that you do use those correct values as the basis for your design, or that you set up your sketches in a way that can be easily updated. The first thing that I want to do is I want to begin by creating the rim portion. Now, when we take a look at this, remember that from the front view, we have two separate sketches that are essentially identical, but one is the location of the design, the hub, or the center section of the rim itself, and the other is going to be the location of the rim. So we're going to have to use both of these as references because we need to know where the lip of that rim is going to go, and then we need to create that geometry. So let's get started by creating a new sketch. We want to make sure that we select a plane, in this case our front plane or XZ. And I'm going to begin first by creating a horizontal reference line. And I'm going to create a vertical reference line. Now, there's a few reasons for this. I'm going to hit Escape to get off my line tool, select both, and convert them to construction. Now, one of the main reasons I like to create the horizontal reference line is because it makes it easier for me to go in and to create my diameter values, my dimension values. The vertical reference line is good if we need to use it to help define any angles or the position of any specific features. Because we are designing or developing an image and 3D model for a mechanical part, then I am going to use specific dimensions to help control it. So right now, we have the flat lip image shown for where the rim needs to go. So we know that the front and the back positions are not correct in this image, but we know that the sandwich position for this rim is correct. So what I'm going to do is I'm going to create a small set of reference lines, and the reference lines are going to come straight down to my construction, and they're going to come straight down here as well. I'm going to hit Escape. I'm going to turn these both into construction by using X on the keyboard, but you can also come over and use the sketch palette. And then I'm simply going to put them in the correct position. I am going to make them both equal. These are just reference lines for right now. And then I'm going to give them a value. So D on the keyboard is the dimension tool, or you can grab it from the dimension tools in the Create section. I'm going to start by selecting my horizontal construction line. Then I'm going to select the end point of one of the lines. Before I left click to place this, I want to right click and turn this into a diameter dimension. So this diameter dimension is going to represent the diameter of that section of the rim. Now remember, we're dealing with a 17-inch rim. So if I make this 16 inches, for example, that's going to be the position of the inside of the rim at this section. Now, if you don't have any experience with mounting tires, especially if you have never taken a tire off or had a rim with no tire on it, then it's important for you to understand a few things. The geometry of the rim itself is important to ensure that the bead portion of the tire can actually seat once it's under pressure. So in this case, the image is showing us essentially a vertical edge. Now there is usually a little bit of geometry here. Some companies will, maybe the inside section will be a little bit rougher for some more grip, and the geometry on the tire itself will be as well. But a lot of times you'll see these sort of sunken sections, and it's not just for looks. These sunken sections are there to ensure that it's easier to mount and dismount tires. So in a lot of cases on motorcycle rims, you'll see the center section sort of swoops down and kind of arcs back in. And this is there so, again, it's easier to mount and unmount the tire. And the reason for that is because if the tire or if the rim was straight back all the way, you would not be able to stretch the tire over the lip on the opposite side of the rim. So for example, if we zoomed out a little bit, in order to get the lip of the tire off of the rim here, the bead on the other side needs to be sunken down into this section. Now, the amount kind of depends on the stiffness of the tire, the geometry that we're dealing with. Extremely large truck tires, for example, like a 38-inch tire on a 15-inch rim, is not as big of a deal as a low-profile street tire. But this geometry is important for mounting and dismounting tires. So having that in mind, knowing that it's not just for looks, we are going to try to replicate some of this geometry to make sure that it works. But remember, that geometry is coming from our second image. This is where we actually need the rim. The first thing that I'm going to do is I'm going to start by sketching everything as accurate as possible. So I'm going to start at this point here. I'm going to come back straight. And then in Fusion 360, I'm going to go back to the last point and hold down my left mouse button to create an arc. I'm going to let go to position that. You'll notice that the tangency is sort of coming out at an angle. I want this to be vertical, and I'll go back and I'll fix those constraints later. So vertical, then I'm going to come back, left click to turn that into an arc. And then you'll notice that this isn't exactly straight. Now it could just be the image underneath it, but I am going to try to mimic this. Now we don't have to build arcs everywhere. We can come back and add fillets. So if we want to just sort of go to that position, we can simply go down, come back, and then we're going to come over to our reference. And that's exactly why we put that reference there. So now before we go any further, let's go ahead and add some dimensions and some constraints. So this arc and this line need to be tangent. This one here needs to be tangent. And then I need to figure out where everything needs to be. So I want to do this before I get too far into the process. I'm going to go sketch dimension. I'm going to come from my horizontal construction line. I'm going to come up to this point or this line. Remember, this line is horizontal, so it should be parallel to our reference. So either this point or this line will work. So remember that we are working in diameter. So we're going to zoom out a little bit, right click, make this a diameter value, and then we can figure out what that size needs to be. 17.75 is probably where we need to be. You can see that it's a little bit below the image, but remember we scaled and skewed these things a little bit. So again, this is a visual reference. We're not trying to produce this rim. We just want to make sure that it looks right. Then I need to add a value for this fillet. Now you can see that it's pretty close to 0.875, but that's a 0. So that's 0.0875 inches. That's pretty small. This line here right now is perpendicular. It automatically added that perpendicular reference to this horizontal line, and that's fine, but we need to determine exactly where this needs to fall in relation to the end point, and this is still free to move. So let's go ahead and add a dimension from there, and let's go all the way back to a position that makes sense for us. So there are a couple different ways that we can do this. We can dimension directly to the origin if we want to use that as a reference, or we can figure out what it is to our construction reference line for where this thing is sandwiching. Now, if you happen to be doing this in order to order a set of custom rims and you want to figure out things like the offset, how much the lip is on the front and the back, I suggest that you do it based on this reference line. But keeping in mind that we didn't actually put any dimensions on these reference lines. So I'm going to hit escape, and escape again to make sure nothing's selected. Then I want to add some dimensions to my reference lines. So I'm going to do 0.425 for their width, and then I'm going to give them a reference dimension of 1.15. So that's pretty close to where they were. And again, these images have been scaled and skewed. So perfect doesn't really matter in this case. We just went close enough. So now that I know where that is, I can start to dimension things from it. So I can go from here to that point, and that's really close to 5 inches. So I'm just going to say 5 inches. And then I can determine the width of this. It looks like it's about 1/8 of an inch, so I'll do 0.125. Now you can see these sketch elements are starting to turn black. They're starting to become fully defined. Now I'm going to add a value to this radius. 0.1875 is pretty close to what it looks like now. And we need to figure out exactly where that falls. This is a vertical line, so there are a couple different ways that we can do this. We can come and do a horizontal vertical constraint. We can make the center point horizontal to a reference. You can see that it's over constrained, likely because this is already happening based on the geometry. And we can also define a value for where this ends up and what this angle is. So again, these references, we need to start figuring out how we're going to do it. I'm going to come down to this horizontal line, and you'll notice that it's coming out at a 4.25 degree angle. I'm just going to go ahead and run with that. It's pretty close. Now here's a word of caution for you. In Fusion 360, if we define the position of this point between these two lines, and then we add a fillet to the sketch, it's going to throw up all kinds of warnings saying that it's now underdefined and we need to sort of fix that. I'm going to go ahead and add a fillet beforehand, and I'm going to make it a nice round number, 0.25. I'm going to repeat the process, right-click marking menu. I'm going to make it larger here. I'm going to do, let's go ahead and let's try a 0.5. And that probably looks okay. It's probably larger than it needs to be, but that's okay. One thing that we need to consider or be aware of when we're doing work like this is that we're going to be offsetting this entire line or segment, polyline, whatever you want to call it. And a small fillet that's external will disappear. It's going to get smaller. So this external fillet will become an internal fillet and it's going to reduce. This internal fillet will become external and it'll increase. So we have to be aware of that when we're making these values. So this 0.5, we could make that 1/4, but you'll notice that it changed the position of this line. So we'll need to move it back down. And this one here, this external is going to get smaller. This internal will get bigger. So this will become more apparent when we start to move things around. Now, D on the keyboard again, we are going to go from our construction line up to here, right click, diameter. And you'll notice that I'm placing these sort of in roughly the same location. It's about 15.5 inches. That's going to be pretty good for me. And then I need to do things like figure out what this angle is. Now I already have a horizontal reference line here. It's about 135 degrees. I'm going to use that as my reference. I can determine how long this line needs to be. 3.14, that's a nice number I like, pi. So we're going to go ahead and use that. And again, these values right now, we're basing them on the image loosely because obviously the image sort of represents a smaller lip. Ours is going to be a much deeper lip because we are going from a 6.5 inch wide rim to a 10 inch wide rim. So now what we want to do is we want to figure out the rest of this. If we hit escape to get off of our dimension tool and we try to move things around, one thing you'll note is that the length of this line, because it's at an angle, is changing. So we can determine the fixed position of this line based on its length value. So D again, I'm going to select this and note that when I move my cursor around, it changes. Before I left click again, I'm going to right click and I'm going to look at the aligned dimension. Aligned is going to be the overall length of this line, not horizontal or vertical. I'm going to give it a value of 0.7 and notice that everything else is now fully defined. So at this point, really what we have is just the front section of the rim. I'm going to use offset. I'm going to select that entire chain and I'm going to offset it vertically. You'll notice that at about minus 0.172, we are pretty close. So I'm going to make this value a little bit more round, minus 0.175, and say OK. Using my line tool, I want to close it off there. And because this line is construction, I need to close it off here as well. Now we have something that can be revolved into a solid body, but we're not quite done because we still need to model the back section. A couple things that we can do here. If we know that we have a mirror line or a center, then we can simply mirror this information across. We don't really have that because we're not dealing with a perfect rim. Obviously, we can use tools like inspect, or we can calibrate, and we can figure out where the middle is. But in this case, let's just go ahead and practice and resketch. So again, line, I'm going to come over here, horizontal line into an arc. We're going to go a little bit quicker this time. Into an arc, this is at an angle, it changes to a straight line here, and then it sort of arcs down. A couple things that we can do to speed this process up. First, let's go ahead and add our tangencies. Make sure that anything that is rounded is tangent. You can see that the arc didn't work here, so we're going to end up adding a fillet there. But now that we've got a couple of those references, let's go ahead and just manipulate this a little bit. And once we're happy with the manipulation, what I want to do is I'm gonna make this angle a little bit different. I want this to bend gradually. Keep in mind, this is the back side of the rim. Now that it's roughly in the right position, let's add some horizontal vertical constraints. So I'm going to take this vertex here, I'm going to make it horizontal with that one. That locks it in that position. Next, I want to take this point, I'm going to go all the way over here and make those the same. So now that position is fixed. I'm going to use dimension. I'm going to come from here to my construction line. I'm going to pick a nice number, 3.75 looks about right. And then I can determine how long I want this to be. I'm going to use the same value as before, 0.125. Something that we can do to make this a little bit easier, I hit escape off the dimension tool. I'm going to double click on that. I'm going to select the dimension from the other side. Let's go ahead and dimension this radius here. We'll select it. I'm going to pull it up. And instead of manually entering a value, I'm going to go ahead and select the one on the other side and make them the same. We'll add a fillet here. For that dimension, it's not going to let me instantly add this one here, so I'm going to hit enter. Then we'll double click on this again, and now we can select this value. So again, what we're doing is we're using symmetry to some extent. We are trying to replicate geometry on both sides. We're going to make that vertical. We want to start to figure out some angles. If this needs to be horizontal, let's go ahead and make sure that it is horizontal. It says that it has a perpendicular reference, and if you're trying to find that, sometimes selecting it and figuring out what other reference there is, like you can see it made perpendicular with this one. So this is automatically horizontal, but the rest of the stuff is sort of free to move around. What we want to do is we want to figure out where this stuff ends up. So this point here is going to be horizontal, vertical with this point. So that automatically locks us in place. Now we can use our dimension tool to add some values. 170 degrees is pretty close visually. I'm going to just set this at 1 inch. I'm going to set this angle at 19 degrees. And now everything is fixed in place. And here is going to be the problem that we were able to avoid the first time. Now I need to come back and add some fillets. So I'm going to make this 0.5. I'm going to make this one 0.5 as well. And notice that now we've got this warning. Constraints and dimensions were removed. Sometimes you'll notice that the sketches are still fully defined depending on how we did our dimensions. This one's based off an angle. This one is based off a dimension from point to point. This happens to still be fully defined. In some cases, you won't be as lucky. Now, here is another interesting challenge that we didn't face on the right-hand side. We offset the right-hand side, but the first line entity and the last one were both horizontal, which means offsetting it is going to have us have a completely set of parallel lines that are vertical at their endpoints. This one, however, is at an angle. Now, in reality, it actually ends at a horizontal. So in order to get that horizontal, I'm actually going to step back a little bit. I'm going to delete this reference. I'm going to delete that arc. And I'm even going to delete this dimension. Now, I have this coincident point here that's sort of left out in space. I'm going to delete that as well. And now what we're left with is some additional lines. We're going to use the line tool. I'm going to come down at an angle, and then I'm going to come over horizontally. Again, we're going to use horizontal, vertical. Make sure that those are horizontal, vertical. Then add some dimensions. We still want to be in the same ballpark, so I'm going to use 20 degrees. Then I'm going to make this line shorter, but now I'm going to hedge my bets and I'm going to put in those angles first. So 0.5, I'm going to do the same thing here, and then I can go back and dimension them. So now I'm going to make sure that this is 0.6. I'm going to go ahead and right click, make this an align dimension. I'm going to say this is 1.15. And now I have a fully dimensioned left side. When we're looking at the reasoning behind these dimensions, it's really just to get the shape generally right. Again, we're not looking at replicating the actual construction of the rim. But now we want to offset this. And when we offset this the first time, we use this 0.175. And notice it's not letting us click that. So I'm just going to hit enter. Then I'm going to double click on this value, and I'm going to come back and click on that. It didn't work, so what we need to do is just put a minus before the D19, and then it'll flip to the other side. Whenever we can use these relationships, especially with things like this rim, whenever we can use these relationships, it'll help us downstream if we ever decide to change anything. Let's go ahead and close that off. And there are a couple more things that we need to do. So at this point, we just simply took this over, we made it straight and terminate directly into where that center reference is going to be. In reality, the rim actually folds down, and you can see that it comes down and sort of creates that lip that we're going to be able to bolt to. Now, we didn't account for that when we sketched it, but we certainly can. So what we're going to do is we're just going to carry this line down. We're going to come back over, and then we're going to come back up. We're going to do the same thing on the other side. We're going to carry that line down, click again to carry it over, and we're going to bring it back up. When we do this, we're going to select each of these lines, and we're going to select one of the little end lines. Sometimes it can be hard to do, so if you hold down the left mouse button, it's going to bring up all of the sketch lines or entities that are wherever your cursor is. We're going to make those three equal. This one's driven by this dimension. These two are now driven by the width or the length of that line, which is driven by the dimension. Next thing we're going to do is select collinear. We're going to make these two collinear. And then we're going to add a dimension. And we want this lip to come down, let's just say 0.7. 0.7 will probably give us enough geometry. In reality, it tapers in a little bit, but for us, this is going to be fine. With this, what we're actually going to do after the fact when we revolve it is we're going to just add a fillet to the solid body. We can sketch it here, but again, keep in mind the intent of this is not to actually make something that we're going to manufacture. It's really just in order for us to get the visual reference right. So now that we have our fully defined sketch, let's go ahead, finish the sketch, and we're going to call this rim lip profile. We shouldn't have very many sketches in this design, so I'm going to take the time to rename all of them. Next, we want to go to Create Revolve. We need to select our profile or profiles. And then we need to select our axis of revolution. This can be the x-axis or it can be that horizontal construction line. We're going to create a new body. Going to go angle 360 degrees. We could also simply set this to full. It's going to do the same thing in this case. And we'll say OK. So now what we've done is we've created that rim. I'm going to hide my blueprint or my image for now. I'm going to go to Modify, Fillet. I'm going to select both inside fillets. Now this one's a little tough on the other side, but let's go ahead and let's add a 1/4 inch fillet. That's a bit too much, so I'm going to change that to an 1/8 inch. It's a bit more realistic. I'm going to go look at the other side. That looks okay. Because this is just a visual reference, we don't have to do it to the inside, but if you want to, we can go ahead and add the fillet to the inside. And here's where it's going to be a little bit tricky. So we added an 1/8 inch fillet to the other side, but remember that we're also dealing with a thickness of 0.175. So if we add 0.175 and we say OK, and we do a quick section view, let's go to Inspect, Section Analysis, and let's just pick this front plane. What we should see is that we've kept it consistent. You can see that it's a consistent thickness all throughout, and that's because we used the radius value on the inside, and when it's offset, it's adding the additional thickness of that 0.175. What we don't have at this point is with that additional offset thickness, we haven't actually gone in and linked it to anything. So if you want to do that, we can go to Modify and change parameters. We can go into our sketches. Remember, we renamed our sketch Rim Lip Profile. We can find that offset value, that 0.175, and we can just simply find where it is. So minus 0.175 is D19. D19 was the value that we used for the lip. We can change the name of it. In this case, we can call this rim thickness. We can't put a space in there, but we can rename it. And notice that it comes up automatically down here, that one value that we linked. Now, if we come down into the fillet, we can say plus rim thickness. We say OK. You'll notice that it automatically gives us that same value. Where this becomes a little bit tricky is the fact that we have positives and negatives. So rim thickness right now is minus 0.175. So if we're adding a minus 0.175, it might give us a negative. So here it gets kind of tricky, and really the best way to go about this is really to create what's called a user parameter. So let's call this rim thick because I already took the name rim thickness, and we're going to make this 0.175. Now, when we come down here, instead of renaming this rim thickness, we'll put this back to D19. It fixes that reference for us. Now we're going to say minus rim thick. So now what we did is we went in and we made that minus rim thick. Notice that the other one that was linked to it, that other minus 0.175, we can't really find it. So before it was linked to D19, now it's minus D19, but we can also change this to minus rim thick. We can also click on it once it appears, say enter, make sure that the value works. Down here, what we're going to do is we're just going to say plus rim thick, because now it's a positive value. It's something we manually created, and now it's okay. We've broken a few things in our sketch and our model, so let's go back and let's edit the feature. This is 0.125. It's got one edge selected, and what it's telling me is that it lost the other edge. So we need to hold down Control on a PC or Command if you're on a Mac. And then we need to fix fillet 2 as well. So let's go ahead and edit this one. Again, you can see it's got one edge. If we hold down Control or again on a Mac Command, then what we're looking to do is we're looking to make sure that those are the same. It looks okay. It's a value, it says fx, the radius is based on some sort of equation, which we know because we created it. And now if we go to the front, everything looks okay. They don't appear to line up, but remember this is based off of our sketch. What you can see is that the original sketch, we actually made this section lower. That horizontal constraint we used, we offsetted it the wrong way when we flipped those dimension values. So in order to fix that, we're going to go back to change parameters. We're going to go back to this offset value, and now it doesn't need to be negative anymore. It can be a positive value. That flips it back the right way, but unfortunately, that's why we had to fix the fillets in the first place. So let's go fix them again one more time. Control or Command, depending on if you're a PC or Mac, and then we'll do the same thing over here. Anytime you create or remove faces based on changes to sketches or features, you will have that problem where you have to go reassociate them. So that was a lot of extra work just to get to that point. But if you are designing parts, or if you're just replicating them and you want the ability to be flexible, you can use those modify change parameters to help you create sketches that are flexible in that nature. So for example, we could create one called rim, DIA for diameter, and we could make it 17 inches. So now in any sketch that references rim diameter, if we go back into this lip profile, for example, so if we have a sketch that we know is going to represent the diameter of the rim. So this one here, 17.75, was up to this section, right? So it was the rim diameter plus a little bit. What I can do is I can change this to rim DIA, and then I can add that 0.75. So that 0.75 value is going to be the extra amount we need to seat the bead. So again, now we can go back in and we can make changes. Just in case this doesn't work, let's do a quick save. Then we can go into modify, change parameters. Let's pull this down just so we can see how it changes. And let's say that we wanted this to be an 18-inch rim. So 18, hit enter, and now it increases the size of that lip. Let's put it back to 17, and it reduces it. Keep in mind in this specific case, we didn't dimension the rest of the rim based off of that value. If you want a design to be flexible enough to update based on those parameters, then really what you should do is make sure that they are all related to a reference point. So if we're going to be using 17, then maybe we'd draw a horizontal construction line, and then everything would be defined off of that. This design is not going to work that way because I'm only doing it as a visual reference, but we could simply go back and fix the sketches. We could redraw some of our references. I don't think it's worth it at this point, but this has at least gotten us a great starting point. We have the rim on both sides, and now the hard part is pretty much done. The rest of it is going to come down to the design that we want to replicate. For now, I'm going to go ahead and save this to make sure I don't lose anything. If you guys have any questions, please let me know. Always thanks for watching, and we'll see you in the next one.